Alright, hello, Assalamualaikum. Today I'm going to show a simple process on how to use reflex. First, for any project, I'll put it in a specialized file where I label it GPS process. And then let's say if I have a new project, um, I'll copy the raw data from the GPR into an ASCII file, so that the raw data from the GPR can be imported from here, right? Not from the raw data here, but from ASCII. And then I'll just confirm the project, 2D data analysis, and then you import the data. So the data is from GPR OTC, and I'll put it as an original name, nanosecond for the time dimension. Conversion sequence, I'll put it as parallel lines. Okay, and then I'll just put convert to reflex, and see it goes straight to the ASCII folder that I've told earlier. And then you notice there's because I've done up until M line. So all I have to do is just press star dot dot and then press enter, and then you just select all the lines needed. Alright, open, and then it'll process the lines, import the lines. Okay, exit. So you can just view back all the lines. This is line M, and then you just click previous. This is line L. Okay, you can see all the hyperbola. Okay, just previous. Okay, so for if I want to process it until I can create a time slice using these lines. So I have to pick one of these lines that has the most clear vision, or clear, what I call that, the hyperbola is really crisp, it's really clear. So let's just browse through. Okay, I'm just browsing through. Okay, because I've already reached line A here, so I think I'll choose okay, I'll choose this line. Okay, because of this hyperbole, and then I can see several hyperbole here. Alright, so the first thing that I do is I'll do sorry I'll do a 2D filter. It doesn't matter if which process you start. Sometimes I can do like a static correction, where I'll do a dynamic, because each transmitter has its own dynamic value here. Alright, signal to receiver distance is like 1 meter. This is already keyed inside reflex, so I'll just put in label 1. Okay, and then sequence process, add. Okay, start. See, I've done one process, and then I just switched it from this to this. Okay, so this is the current value or current line that I've done the dynamic correction. And then the next thing is I need to cut off the what called the space between the receiver and the ground. So what I do is I'll just view the wiggle window, and then I'll click auto size. Yeah, this is the wiggle for each trace. Okay, uh, for this to appear here, you can just click. Okay, you can just click here. It's the same actually, but it's too cramped, so you can't view the individual lines. So you just have to do it again. Okay, so we'll view back the wiggle window. So I just want to cut off all the area between the receiver and the ground. So I'll choose the first peak here. Okay, this is the first peak. You notice that sometimes the value is different because the surface of the ground is uneven. So we'll just have to average it. Okay, so let's say if I choose here. Okay, just remember there's a value here. This value you have to remember because it will be used to cut off the zero time removal. Okay, 3.4924. And then you go to processing, static. Okay, move start time, manual input, and then you put 3 3 sorry 3.4. Okay, and then because you've already entered one value. Okay, so here's the difference, you see. All right, so I just add because I have to restart back, so I just add the move start time, hit close, and then change. Okay, next step is the background removal. And then add start. So it removes all the background noise if possible. Okay, and then next. Okay, I like to do what I call this. Oh, sorry, 1D filter and band pass butterworth. Okay, I click on this hyperbola that I see here, and then it goes straight to this number, trace number 882, and then here is the spectrum. I just want to filter out which one I don't want. So let's say if I cut here, just lower cut off is here. See, it automatically kicks here, and then upper cut off you put it here. So here's the filtered spectrum. Okay, you put a filter from here till here, so then you just erase all this part. So let's see how it goes. It's much more cleaner. Okay, the line is much more cleaner. You can just try it again. You put it here, and then let's see, put it here, and then you start. See, it's, but you notice that we have a hyperbola here. When I choose this one here, it's kind of like disappeared, right? This value here. So you have to be careful which value you choose, because you don't want to lose out all the data, all the findings. So this one is I can see a little bit from here, and then I can see a couple here, here, up here, up here. All right, and then one maybe here, and then I just add the sequence, add, see, close, then I just switch. Okay, let's say if I want to see a stronger what I call this scan, so I just add gain function. As we know that all GPR radar has an exponent value whenever they travel into the ground. So the signal has a power loss of an exponent features. So let's say we don't know the true value. We just put one. Okay, we have to raise the label here. Okay, so okay, then we have to experiment this value. Okay, notice it, here is the original signal, here is the filter. You just want to uh, make it more louder here without adding more noise here. So you just try. Alright, okay, you notice it's getting bigger. So this is noise, noise. You don't want this. Alright, you just want a clear version here, so you just put it down a little bit. Alright, so it's much more clearer than this, and then you try. See, it's much more clearer, it's much more clearer, but there's noise here. All right, this is noise, but if it helps with the findings, then you can put it in your sequence. Current, exit, start again, close, change. And then for the last step, okay, for me, I like to measure the velocity of the wave. Okay, this is 0.1, but I think it's a little bit slower because the hyperbola doesn't fit my mouse, except this one kind of fit, but okay, because I think it's a little bit slower, so I'll just put it here. It's much more slow. 8. See, it's much more fitter. It fits, all right, but it's smaller in size. Nope, that's the width. Okay, it fits. Yeah, yeah, this is just what do you call that, it takes into a consideration that it averages all the values, because we have to know that not all the hyperbola has this same value. Sometimes it's much more bigger, maybe there's a water, I mean, like there's what do you call that, pipe burst or something like that. It or maybe it was raining prior to the day of scanning. So those conditions really affect the GPR results. So okay, just remember 30 LA. Okay, just turn it off, or maybe turn it off. Processing, and then you just do migration, reflection, summation width is 30, so you have to multiply it by 2, so it's 60. Velocity is 0.8, and then you just put another value here. Not yet, we have to check first. Okay, we process it. Okay, this is the different. Okay, it becomes a neat feature. It's not, it doesn't become like this is a hyperbola. It collapsed the hyperbola into a neat feature. Neat is something like a compact. It becomes like a rectangular here, and then here you can see 3, 1, 2, 3, 1, 2, 1. Okay, so this is all the finding that it fits. So maybe all these value, they have the same value. All right, so you just add the current sequence, then you just exit, close, change. All right, okay, you can let's say if you want to see it much more clearer, you can just add on the plot scale value. All right, but yeah, more value, more noise, we don't want that, so I just put it here. Okay, we've done for line L. So right now I want to do for all the lines. Sequence process, this is the one that we've saved up. So usually I put it here. Let's say I put 10. I like to put it the final process label as 10, and then I'll put it as raw data star dot dat, start several lines. Okay, and then I select all those lines here, open, and then it'll process all the lines. So you don't need to process individually, you just pick one that has a clear value, and then you use the same process to process all the other lines. Okay, now we're done. Exit. Okay, sorry. Okay, then we can just exit this. Yes, and then go to the 3D file, open 3D raw data. Sorry, we have to use it from prop data. Okay, and because I put the processing level at 10, so you have to put star dot 10t, enter, and then select all these, Oops, sorry. Oh, sorry, this is 3D. You just have to generate 3D from 2D lines. Okay, let's say if you want to name it as block 1, and then equidistance, sort by file names, line increment. This is the increment between each scan. During scanning, I put the line increment as 0.5 meters, and then here remember the 10t, and then load to the files. See, it goes back again here, select all, open. Okay, and then you just click start. Okay, so here envelope closed. Okay, here are the 3D lines where you can watch the slices. Okay, currently one of those lines, it has a, what do you call that, see, one of those lines is incorrect, so I have to select which line is not proper, or which line has a error in it. So I have to generate back. Okay, let's say if I close it back and then open the prop data. Star.20. Okay, I'll check whether the lines are proper or not. Let's start from line A. So this is line A. Okay, line I. I is problematic because it has a distance value of 800. So close it, open this back again, generate 3D lines, block 1A, and then this one, 10t, 0.5, load. Okay, I won't be loading line I, so just select all except line I, open. Okay, between line HIJ, this becomes a 1 meter increment, so you have to remember this HIJ. Okay, and then I just press start. I close slices. Okay, so it becomes a slice. It cuts the scan from top to bottom. Okay, you can just press start here. Okay, you can view all the slices here. So, or you can just scroll through here. Okay, I usually use blue, gray, red here because it gives off we call that different feel when you're looking for utilities. Okay, currently it's hard to find the utilities. You just have to watch Y cuts, and then you notice there's one here, and then there's another one. You can just pick from here. Pick. Let's say you pick code color 1, 2, 3, 4, 5, 6, 7, 8, so I can find 1, 9, 10, 11. And then notice there's this one line. I think this is a on top of a junction here. So and then we change another code. Okay, 1, 2, 3, nothing here. Okay, and then here we change another code. We'll put it 1, 2, 3. Okay. Okay. So we've already digitized. Basically, we digitized all this, and then we can just view. You can just fast data cube display here, and then you can pick. Where is it? Oh, here. Pics load. Okay, so you can view all the pics here. Oh, sorry. It's a bit small, so we load it back again. See, okay. So here's your findings lah. Basically, here's the finding that we can see from the scan. So here, hmm. So the suspected line, it goes from here, and then it turn to the right here, and then there's one several points here, and then there's one three we call that several lines there. Okay, so here you can view the findings here lah. All right, thank you.